Unit 1, Lesson 4, and word problem number 2. Make sure you're going to start by clearing the RAM on your calculator. Let's begin. The University of Phoenix Stadium, and that's where Arizona Cardinals played, and it's been renamed since this problem was created, opens its gates at 9 a.m. on game day. The attendance can be modeled by the following equation. We're going to graph this in an appropriate window. And so to start with, parts I think students struggle with this problem is the first thing is how do we plug it in correctly? Well, notice we have kind of a complicated equation here. So we're going to put parentheses around the 70,000 on top. And we're also going to put a second set of parentheses around the bottom portion. So 1 plus 5931 times 3 raised to the negative 3.7. And now we don't look for the h, we're going to use an x. Okay, I'm also going to come up to the windows and it sets the windows. So we have two concepts here. We have time after 9 o'clock and we have a population that is entering into the stadium. So how many total people at any given point in time after 9 a.m. So it tells me to set the h, the hours, and remember time is always going to be your x's, between 0 to 8, and then I'm going to do zoom fit, which is zoom 0. This is a nice looking graph. So how do I correctly fill this out? Well, I draw this shape and then it's important I fill these out. Where do I find these numbers for the x and the y minimum and max? After I have a nice looking graph, I come up here at window and I would just write in 0 and 8 for the x minimum max, and I would put this 11.8 to 70,000 for the y minimum and maximum. Again, this is a model. It's not going to be necessarily precise. We can't guarantee this is how many people will be there at a certain time. It's just a model, an approximation. Let's get started with part B. Part B says how many fans will be in attendance at 12 o'clock. So just like our previous word problem, we're going to go with what's the initial down to what is the given time right now. And the difference is 3. So I'm going to come up and do second trace value. It's a whole number of 3, and we can assume there'd be 67,961 people in the stadium at 12 o'clock. Okay, similar to part B, the first thing we're going to do is we're going to count what is the difference from 9 a.m. to 1:05. That's a difference of 4 hours, but we got this partial. We have a leftover amount of minutes. We ask ourselves how many minutes are there in 1 hour? There would be 60, and this is how I plug it in. Second trace value, 4 plus, and in parentheses, 5 divided by 60. So we can assume at 1:05 p.m., the stadium would have 69,974 people in attendance. Okay, this time, just like part D on the first word problem, they're going to provide us with the total population, which is your Y value or your A of H. And we want to know what is the X. So I'm going to come up to Y sub 2. Plugging in 40,000. I have seen students in the past make mistakes trying to put a parentheses down to mimic what we see on the screen right now. Don't do that. And we want to see where does it intersect. Second trace, intersect is number 5, and pressing enter 3 times. Now we want this answer to be in terms of hours and minutes. So I'm going to write down x equals 2.2081002. This is easy. What does this represent? It represents 2 hours after the initial time. So we can assume that at 11 o'clock, and now I need to turn this partial, which is 0.2081002, and I ask myself how many minutes an hour. There are 60. So we can assume at about 11:12 a.m. on game day, the population in the University of Phoenix Stadium will be 40,000 people.